Come with me. Imagine for a moment that we're standing on the shore of a vast cosmic ocean. The waves lapping at our feet are not of water but of space-time itself, carrying whispers of distant galaxies and ancient stars. This isn't just a metaphor, it's the reality of our existence, perched on a small blue world, looking out into an immensity that really defies our everyday comprehension. We are about to embark on a journey, a voyage of discovery through this grand arena. We'll travel from the familiar landscapes of our own solar system to the mind-bending frontiers of the observable universe, exploring phenomena that challenge our very notions of space, time, and reality. Our vessel for this exploration is the most powerful tool we have ever devised, the human mind, guided by the principles of science. In the coming moments, we will uncover some of the most astonishing truths the cosmos has to share. These are not just trivia, they are profound insights into the workings of the universe, each one a thread in the magnificent tapestry of cosmic evolution. From the impossible density of dead stars to the slow, stately dance of planets, each fact is a portal to a deeper understanding. So, quiet your mind, open your senses, and prepare to be astonished by the sheer wonder of it all. We invite you to join us on this odyssey, to cast off the moorings of the mundane and set sail for the stars. The universe is telling a story, the grandest story of all, and we are privileged to be able to listen. The facts we'll explore are more than just data points. They are clues to our own origins, our place in the cosmos, and perhaps our ultimate destiny. We'll navigate through storms that have raged for centuries, past worlds made of diamond, and towards collisions of entire galaxies. This journey requires only one thing from you, your curiosity. Stay with us until the very end of our voyage. The cosmos saves its most tantalizing secrets for those with the patience to seek them. Our final destination will reveal a possibility so profound, so close to home, that it could reshape our perspective on life itself. The universe is full of surprises, and the greatest one might be lurking in our own cosmic backyard, waiting for us to find it. The journey begins now. Let's step into the spaceship of the imagination and see what wonders await. Consider a simple act. You throw a ball into the air. You know with an innate certainty born from a lifetime on Earth that it will slow down, stop, and fall back into your hand. Gravity is the great cosmic leash, pulling everything back. For most of the 20th century, we cosmologists thought the universe behaved in a similar way. We discovered it was expanding, yes, but we assumed the mutual gravitational pull of all the galaxies, all the stars, all the matter within it, would act as a brake. We believed this cosmic expansion was slowing down, destined to either coast forever or perhaps one day reverse in a big crunch. But the universe, it seems, had a surprise in store for us, a plot twist of cosmic proportions. In the late 1990s, two independent teams of astronomers were observing distant supernovae, using these standard candles to measure the expansion rate of the universe at different points in its history. They were trying to measure precisely how much the expansion was slowing down. What they found was so shocking, so contrary to all expectations, that at first, they didn't believe their own data. They checked and rechecked their calculations, searching for any possible error that could explain the bizarre result. The data was relentless, its conclusion inescapable. The expansion of the universe isn't slowing down at all. It's accelerating. It's speeding up. Imagine throwing that ball into the air, and instead of falling back down, it shoots away from you, faster and faster, into the sky. This is the universe we live in. Some unknown force, some mysterious energy inherent in the fabric of space-time itself, is pushing everything apart. We've given this mystery a name, a placeholder for our ignorance, dark energy. It's a force that counteracts gravity on the largest scales, a cosmic anti-gravity driving the universe into a runaway expansion. This discovery fundamentally changed our understanding of the cosmos and its ultimate fate. It was a moment of profound humility, a reminder that our assumptions are merely signposts on the road to knowledge, not the destination itself. The universe is not the clockwork mechanism Newton envisioned, nor the slowing, majestic cosmos Einstein first calculated. It is something wilder, more mysterious, and far more dynamic. We live in a universe that is not just expanding, but actively pushing itself apart with an ever-increasing velocity, a fact that has staggering implications for the far future. Let's travel now from the edge of the observable universe back to our own cosmic neighborhood, to a planet that has long captivated the human imagination. It is the second planet from the Sun, a world named for the Roman goddess of love and beauty. But Venus is no paradise. It is our sister planet, nearly the same size and mass as Earth, but it is a sister who has taken a radically different path. Shrouded in a thick, toxic blanket of carbon dioxide clouds, its surface is a vision of hell, a crushing pressure 90 times that of Earth's and a searing temperature hot enough to melt lead. This world, our celestial twin, holds another secret, one that is less dramatic than its runaway greenhouse effect, but in many ways just as strange. It concerns the very rhythm of its existence, the fundamental beat of its daily and yearly cycles. On Earth, we are accustomed to a simple and reliable pattern. Our planet spins on its axis once every 24 hours, giving us the familiar cycle of day and night. At the same time, we orbit the Sun, a journey that takes approximately 365 of those days to complete, defining our year. This rhythm is the bedrock of our lives, our calendars, our biology. But on Venus, this familiar relationship between a day and a year is turned completely on its head. This planet is a cosmic anomaly, a maverick that spins to its own incredibly slow beat. While Earth completes a rotation in a brisk 24 hours, Venus takes its time. It rotates so lethargically, so languidly, that it seems almost frozen in place. This sluggish spin is one of the most peculiar features in our solar system, a puzzle that planetary scientists have worked for decades to understand. It's a world where the sunrise is not a daily promise, but a rare and protracted event. The consequences of this slow rotation are profound, shaping everything from the planet's climate to its very geology. It's a world without the familiar Coriolis forces that drive weather patterns on Earth. A world where day and night are not fleeting moments but geological epochs. To truly grasp the strangeness of Venus, we must let go of our earthly conceptions of time. We must journey to this furnace world and imagine standing on its surface, waiting for a sun that seems to take an eternity to cross the sky. It is a place where a single day lasts longer than an entire year. Come with me to a place where numbers lose their meaning, where the human mind struggles to grasp the sheer scale of existence. We often seek familiar analogies to comprehend the cosmos, to bring its immensity down to a human scale. Consider the sands of all the beaches on Earth, every desert dune, every grain hidden in the deepest oceans. Imagine scooping up a handful. The number seems vast, perhaps even infinite from our limited perspective. It's a classic metaphor for a number so large it's beyond counting, a poetic expression of the innumerable. Yet the universe, in its quiet, staggering grandeur, presents us with a reality that dwarfs even this profound image of endlessness. The human brain, a magnificent product of evolution, is wired to understand the world around us. The distance to the next river, the number of predators in a pack, but it was not built to intuitively grasp the numbers that describe the cosmos. When we speak of billions and trillions, they become mere words, abstract concepts that fail to convey the physical reality they represent. The number of sand grains on our entire planet is estimated to be around 7.5 quintillion. That's a 7 followed by 18 zeros. A number so colossal it's hard to hold in your mind. But in the cosmic ledger, this is just a starting point, a humble entry on the first page of an endless book. The life of a star is a dramatic cosmic ballet, a lifelong struggle against the relentless inward pull of its own gravity. For billions of years, the outward pressure from nuclear fusion holds gravity at bay, creating a delicate equilibrium. But all stars, like all living things, must eventually run out of fuel. For stars much more massive than our Sun, their death is not a quiet fading, but a cataclysmic explosion known as a supernova. In a final brilliant flash, the star outshines its entire galaxy, scattering its hard-won heavy elements across space to seed the next generation of stars and planets. But what happens to the core? What is left behind after this spectacular celestial fireworks display? For the most massive stars, the core collapses under its own immense gravity, crushing itself down so completely that it tears a hole in the fabric of space-time itself, forming a black hole. But for stars in a specific mass range, something else happens. The core collapses, yes, but it stops. It is caught in a new state of equilibrium, creating one of the most extreme and bizarre objects in the entire universe, a neutron star. A ghost of a star, a cosmic tombstone of unimaginable density. For millennia, humans have looked to the mountains of Earth with a sense of awe and reverence. They are symbols of power, permanence, and the formidable forces of nature. We have measured ourselves against them, climbing their peaks to prove our endurance and to gain a new perspective on the world below. Mount Everest, the highest peak on our planet, rises to a majestic 8.8 kilometers, about 5.5 miles, above sea level. It is the pinnacle of our world, a geological wonder sculpted by the slow, grinding collision of tectonic plates over millions of years. But our solar system has a different story to tell. On the rusty, windswept plains of our neighbor Mars stands a mountain that makes Everest look like a mere foothill. It is called Olympus Mons, the Mount Olympus of the gods. This is not just a mountain. It is a volcano of truly epic proportions, the largest known volcano in our entire solar system. Its peak towers an astonishing 25 kilometers, or about 16 miles, above the surrounding plains. It is nearly 3 times the height of Mount Everest. If you were to place Olympus Mons on Earth, its peak would soar far above the cruising altitude of commercial jetliners, punching through most of our planet's atmosphere. We often speak of the vacuum of space, a term that conjures images of perfect absolute nothingness, an endless sterile void, utterly devoid of matter. It's a concept deeply ingrained in our collective imagination, a backdrop of pure black against which the cosmic drama unfolds. We picture astronauts floating in this silent emptiness, a stark contrast to the dense, bustling world we inhabit. This idea of a perfect vacuum, however, is one of the grand misconceptions of the cosmos. It simplifies a far more intricate and dynamic reality, one where even the most seemingly empty stretches of the universe are teeming with a subtle yet profound presence that shapes the very fabric of existence. The truth is, space is never truly empty. It's more like a cosmic ghost town, seemingly abandoned but filled with the faint whispers and lingering traces of its inhabitants. If you were to venture into the vast gulf between the stars, into what we call the interstellar medium, you wouldn't find absolute nothingness. Instead, you'd find a diffuse, almost ethereal soup of atoms, molecules, and dust. It's a realm of extreme scarcity, a place where matter is spread so thinly that our earthly intuition struggles to grasp it. This isn't the bustling metropolis of a planet's atmosphere. It's the loneliest, most desolate desert imaginable, yet it is not, and can never be, truly empty. In our everyday experience, cold is simply the absence of heat. We bundle up in winter, seeking warmth from fires and furnaces to combat the chill. But in the grand scheme of the cosmos, what is the ultimate limit of cold? Is there a point where you simply cannot get any colder? The answer is yes, a theoretical limit known as absolute zero. This is the temperature at which all classical motion of particles ceases. It's not just chilly, it's a state of perfect crystalline stillness at the atomic level. On the Kelvin scale, which measures temperature from this absolute floor, it's 0 Kelvin. On the Celsius scale, that's a mind-numbing minus 273.15 degrees. This concept of absolute zero is more than just a number. It's a fundamental law of physics, the third law of thermodynamics. It represents a state of minimum possible energy. While quantum mechanics tells us there's always a tiny bit of residual zero-point energy, for all practical purposes, absolute zero is the ultimate cold. Nothing in the universe can ever reach it, though it can get tantalizingly close. The universe itself has a background temperature, a faint afterglow from the Big Bang known as the cosmic microwave background radiation. This ancient light fills all of space, giving it a baseline temperature of about 2.7 Kelvin. For most of human history, time was thought to be an absolute, a universal clock, ticking at the same rate for everyone, everywhere. Isaac Newton envisioned it as a great cosmic river, flowing inexorably forward, unaffected by anything in the universe. An hour on Earth was an hour on Jupiter, and an hour near the most distant star. It was a comforting, intuitive idea, the steady, unchanging backdrop against which the motion of the planets and stars could be measured. This rigid, unyielding concept of time was woven into the very fabric of classical physics for centuries. It was simple, elegant, and as it turned out, incomplete. Then, in the early 20th century, a young patent clerk named Albert Einstein completely shattered this notion. With his theories of special and general relativity, he revealed a far stranger and more fascinating reality. Time, he showed, was not absolute. It was relative. It was not a separate, independent entity, but was instead woven together with the 3 dimensions of space into a single, 4-dimensional continuum, space-time. And this space-time fabric was not a rigid stage. It was a dynamic, flexible entity that could be warped and curved by the presence of mass and energy. Out here, in the vast dark ballroom of the cosmos, everything is in motion. Nothing stands still. Galaxies, these immense islands of stars, gas, and dust, are waltzing through space-time, pulled by the invisible hand of gravity. Our own cosmic home, the Milky Way, is no exception. It pirouettes through the void, a swirling disk of hundreds of billions of suns. But it is not alone in this dance. Another, even larger galaxy is moving towards us, a cosmic partner, or perhaps a rival, on a trajectory that has been set for billions of years. This is the Andromeda Galaxy, our nearest major galactic neighbor, and it's headed our way. This isn't a gentle approach, a slow, courtly bow. This is a high-speed, headlong rush. Andromeda is hurtling towards the Milky Way at a staggering speed of about 110 kilometers per second. That's fast enough to travel from New York to Los Angeles in under a minute. For eons, astronomers looked at Andromeda through their telescopes, seeing its faint, fuzzy light, knowing it was out there. But its true motion towards us was a subtle secret, revealed only by the faint blue shifting of its light. This shift, a cosmic Doppler effect, was the telltale sign, the cosmic announcement of an approaching giant. For most of human history, we knew of only a handful of planets, the wanderers we could see with the naked eye. But with the advent of powerful telescopes and clever detection methods, we've unveiled a galactic menagerie of worlds beyond our wildest dreams. We've found gas giants hotter than stars, planets orbiting two suns, and rogue worlds drifting alone in the dark. Among this stunning diversity, there is one that truly captures the imagination, a world that seems plucked from a treasure chest. It's a planet named 55 Cancri E, and it might just be a diamond in the sky. Located a mere 40 light-years away in the constellation Cancer, 55 Cancri E orbits a star much like our own Sun. But that's where the similarities end. This planet is a super-Earth, about twice the size of our world and over 8 times more massive. It orbits its parent star at a blistering pace, completing a full year in just 18 hours. It is tidally locked, meaning one side perpetually faces its star in an eternal, scorching day, while the other is locked in an endless, frozen night. This extreme proximity to its star subjects its surface to unimaginable temperatures. When we look up at the night sky, we are not just looking out in space, we are looking back in time. The light from the moon takes about a second to reach us. The light from the sun, 8 minutes. The light from the nearest star takes over 4 years. Every photon, every particle of light that strikes our eyes or our telescopes is a messenger from the past. It carries with it a story of its origin, a snapshot of a moment long ago. This fundamental truth, the finite speed of light, is the key to measuring the cosmos. It is both our greatest tool and our ultimate limitation. Because light travels at a fixed cosmic speed limit, there is a horizon to what we can see, just as a ship on the ocean sees a horizon beyond which it cannot see the sea. We have a cosmic horizon. This isn't a physical barrier in space, but a horizon in time. The universe we know had a beginning. It began about 13.8 billion years ago in an event we call the Big Bang. Therefore, the absolute farthest we can possibly see is the distance light has had time to travel since that moment. Any light from beyond that point simply hasn't had time to reach us yet. Imagine a storm, not the kind that rages for a few hours or even a few days, bringing thunder and rain before giving way to clear skies. Imagine a storm so immense, so powerful, that it has churned relentlessly for as long as we humans have had the telescopes to see it. This isn't science fiction. It's a reality playing out hundreds of millions of kilometers away, in the turbulent atmosphere of the giant planet Jupiter. We call it the Great Red Spot. It's a vortex of cosmic proportions, a hurricane that has outlasted empires, revolutions, and the entire history of modern science. It's a testament to the sheer scale and power of planetary dynamics, a persistent, swirling eye staring back at us from the depths of the solar system. This colossal storm is a high-pressure region in Jupiter's southern hemisphere, an anticyclonic tempest that rotates counterclockwise with a period of about 6 Earth days. Its very existence challenges our terrestrial understanding of weather. On Earth, hurricanes form over warm ocean waters and dissipate when they move over land, their energy source cut off. But Jupiter has no solid surface to speak of, no land to break the storm's momentum. It is a world of gas, a deep, churning ocean of hydrogen and helium, and this storm feeds on the planet's internal heat and the immense shear forces between its atmospheric bands, drawing energy from the planet's rapid rotation. When Giovanni Cassini first observed a permanent spot on Jupiter in the late 1600s, he was likely looking at this very storm. Think about that. While Newton was formulating his laws of gravity, this crimson vortex was already a prominent feature. It has been continuously observed since at least 1830, a silent witness to our own scientific awakening. Its longevity is a puzzle that planetary scientists are still piecing together. What fuels such a long-lived atmospheric disturbance? How does it maintain its structure and energy over centuries? The Great Red Spot isn't just a weather pattern. It's a natural laboratory for fluid dynamics on a scale we can barely comprehend. The sheer persistence of this storm forces us to reconsider our place in the cosmic timescale. Our entire recorded history is but a fleeting moment compared to the life of this single storm on another world. It's a humbling perspective. As we point our most advanced instruments towards Jupiter, we are not just studying a distant planet. We are looking back in time, observing a meteorological phenomenon that was raging long before any of us were born, and will likely continue long after we are gone. It's a constant, a beautiful, violent, and utterly alien feature that reminds us of the enduring power of the cosmos. On July 20th, 1969, a human being did something unprecedented. Neil Armstrong stepped out of the Apollo 11 lunar module and planted his boot onto the dusty surface of the moon. In that moment, he left behind more than just a footprint. He created a monument. A simple impression in the fine, gray regolith, a testament to a journey of 400,000 kilometers, and a symbol of what our species can achieve. That footprint, along with those of the 11 other astronauts who walked on the moon, is still there today, perfectly preserved in the silent, unchanging landscape of the Sea of Tranquility. Think about the most ancient human artifacts on Earth. The pyramids of Giza, the stones of Stonehenge. They have been battered by wind, scoured by sand, washed by rain, and eroded by the relentless passage of time for millennia. They are scarred veterans of our planet's active geology and dynamic weather. But on the moon, these forces are absent. There is no wind to blow the dust away, no rain to wash the impression clean. There is no atmosphere to speak of, no weather to erode the delicate ridges of a boot print. It exists in an almost perfect vacuum, a silent world of stillness. The lunar surface is a museum of cosmic history, and these footprints are its newest and perhaps most profound exhibit. They lie beside the discarded descent stage of the Eagle lander, near the seismometers and laser reflectors left behind by the Apollo crews. These artifacts of human exploration sit undisturbed under the harsh glare of unfiltered sunlight and the profound cold of the lunar night. They are a message left for the future, a signpost that says, "We were here. We came in peace for all mankind." A message etched not in stone, but in dust. How long will they last? Barring a direct hit from a meteorite, which is statistically very unlikely, or the disturbance from a future lunar landing, these footprints will remain for millions of years. Long after the great cities of Earth have crumbled to dust, long after our own civilization has transformed into something unrecognizable, these first, tentative steps on another world will persist. They are a silent, ghostly reminder of a singular moment in the history of life, a fragile yet incredibly enduring legacy of our first journey beyond the cradle of Earth. Come with me on a journey to the outer solar system, past the asteroid belt, beyond the colossal dominion of Jupiter. Here, in the cold, distant reaches, hangs a jewel of our cosmic neighborhood, Saturn. It's a world defined by its magnificent rings, a celestial halo that has captured our imaginations for centuries. But beyond this stunning display of ice and rock lies a secret, a peculiar truth that seems to defy our everyday experience. This gas giant, a behemoth over 9 times the width of our own Earth, possesses a quality so unexpected, so seemingly impossible, that it invites us to reconsider everything we think we know about planets. Saturn, for all its majesty and size, is a cosmic lightweight. Imagine, if you will, a bathtub. Not just any bathtub, but one of truly cosmic proportions, vast enough to cradle worlds. Now picture placing the planets of our solar system into this grand basin. Earth, Mars, Venus. They would all sink, plunging into the depths like stones. Even mighty Jupiter, the king of planets, would follow suit. But Saturn would do something extraordinary. It would float. This isn't a flight of fancy or a scene from science fiction. It is a fundamental truth rooted in the laws of physics. It's a testament to the fact that in the universe, size and mass do not always tell the whole story. Sometimes the most massive objects hide the most ethereal nature. For millennia, humanity has looked to the stars and asked a single profound question. Are we alone? We've scanned the heavens for signals, we've imagined strange creatures on distant worlds, but the first truly compelling answer may not come from a far-flung star system. It may come from our own cosmic backyard. Let's travel back to the realm of the giants, to the dominion of Jupiter. Orbiting this colossal world is a family of moons, and among them is one that shines with a special promise. Its name is Europa. At first glance, it appears as a pale, unassuming orb, crisscrossed with reddish-brown cracks like a fractured porcelain egg. But this fractured surface is a clue. It hints at something incredible hidden beneath. Europa is one of the smoothest objects in the solar system, with very few craters. This suggests its surface is young and active, constantly being resurfaced and renewed from below. The lines that stretch across its face, called lineae, are vast cracks and ridges in an icy shell, some stretching for thousands of miles. They speak of a dynamic, shifting world, a world where the surface is just a thin veil over a much more exciting reality. Scientists now believe, with a high degree of certainty, that beneath this shell of ice lies a vast global ocean of liquid saltwater. We've journeyed together across the expanse of space and time, from the buoyant majesty of Saturn to the tantalizing promise of a hidden ocean on Europa. We have contemplated facts that stretch our minds and fill us with a sense of profound wonder. The universe, in its infinite complexity and grandeur, has revealed just a few more of its secrets to us. From the simple truth of a floating planet to the profound possibility of alien life in our own solar system, each discovery is a stepping stone, leading us further on our great cosmic journey of exploration, a journey that has only just begun for our species. The story of the cosmos is the grandest story of them all, and it's a story that is still being written day by day, with every new observation, every new mission, every new mind that dares to ask what if and why. Thank you for joining me on this leg of the voyage, for lending me your curiosity and your imagination. The quest for knowledge is a shared one, a fire passed from one generation to the next, and it burns brightest when we share our wonder with one another. Your time and attention are the fuel that powers this exploration, and for that, I am truly grateful. This channel is a ship of the imagination, dedicated to navigating the vast ocean of cosmic knowledge. If you've enjoyed this journey and wish to embark on many more, to explore the farthest reaches of the universe and the deepest mysteries of science, then I invite you to subscribe. Join our crew of cosmic explorers as we continue to chart the unknown, to translate the silent language of the stars, and to share the awe-inspiring story of everything. There are always new worlds to discover, new wonders to behold, and we want you to be here with us for all of them. And now, I turn the final question over to you. We've explored so many mind-bending facts today. Which one resonated with you the most? Was it the impossible notion of a floating gas giant, the mind-boggling density of a neutron star, or the hopeful promise of a life-bearing ocean on a distant moon? Share your favorite cosmic fact in the comments below. Let's continue the conversation and share in the wonder together. Until next time, keep looking up.